For centuries, people believed that hell was at the center of the earth, a fiery furnace inhabited by demons. But they were wrong. There are no demons. The heart of the earth, its inner core, is a solid ball of iron and nickel. Here the pressure is so high it never melts, despite the intense heat of 3,700 degrees Celsius. The outer core is under less pressure, so it is molten. This is enclosed by a deep layer of hot rocks called silicates. This is the mantle, and it's 3,000 kilometers thick. The surface is hard and forms a solid crust. If the Earth was a peach, this crust would be as thin as its skin. But the Earth's crust is cracked and brittle, like an eggshell. It's made up of several segments called tectonic plates. There are two kinds of crust. Continental crust forms the great landmasses of the world. This is thick. These rocks are made of ancient lightweight substances like granite. Some were formed almost 4,000 million years ago. Oceanic crust, which lies under the planet's great oceans, is much thinner. Oceanic rocks like basalt are heavy and much younger, 1/20th the age of continental rock. The plates float on the dense mantle. Scientists believe that the immense energy of the Earth's inner heat sets up convection currents in these rocks, which move the crustal plates about, but very, very slowly. Some are moving apart. Some move towards each other. Other plates just slide past one another. These movements in our planet's crustal plates have created some of the most dramatic features of our world. Our mountain ranges, our earthquakes, our volcanoes, and many of our islands. In 1963, Icelandic fishermen spotted plumes of ash, steam, and lava shooting out of the sea. Almost overnight, a new island emerged. Later, this would be named Surtsey. Lava poured out of the earth. The eruptions didn't stop until 4 years later. Within months, birds began to visit and plants grew. But what had happened? At the bottom of the ocean, two plates of continental crust had slowly moved apart. Molten rock called magma, lying below the plates, oozed up through the cracks. When it reached the surface, the magma cooled and solidified, forming lava. This gradually built up until it broke through the ocean surface to form an island. A ridge of lava and mountains has been formed where the two plates have moved apart. This runs down the middle of the Atlantic Ocean. The plates are moving very, very slowly, less than 5 centimeters a year. But over time, this has added up. Since Columbus set out from Spain to discover America in 1492, the Atlantic Ocean has widened by about 25 meters. But what happens when plates move towards each other? Volcanoes like Merapi in Indonesia are caused by the collision of oceanic and continental plates along what is known as a destructive margin. Over millions of years, heavier oceanic plate is being forced down under the lighter continental plate, creating a trench. Carrying water and debris with it, the oceanic plate breaks up under immense pressure. As it's forced down, it gets hotter and hotter, due to friction and because the temperature rises rapidly towards the Earth's center. Eventually it melts, and the molten magma rises to form volcanoes some distance from the trench. Sometimes a row of these volcanoes can form an island, like Java. Millions of years of eruptions have made the country very mountainous and fertile. These volcanoes release ash and rocks that break down quickly into soil, producing new supplies of the minerals plants use to grow. This makes the land very productive. Living in the shadow of Merapi is dangerous. The volcano often erupts. In 1994, it claimed the lives of more than 60 people. So what happens within the volcano to make it erupt? Molten magma from below the Earth's crust pushes up into the mountain. This causes tremors, which can be measured by seismometers. And tiltmeters can actually detect how much the mountain is bulging as it fills with magma. This is thick, like porridge, and when it reaches the surface, it solidifies into a hot, crumbly plug. Pressure on the magma builds up, and bits fall off all the time. The plug, or dome, gets too big and top-heavy. Eventually, it's forced apart. Gas boils out and foaming magma rushes up. Shattered rocks and steam form a huge and heavy cloud that soon falls back to Earth, crashing down the mountain like a bulldozer. It's grey on the outside where it's cooled, but inside are red-hot gas, sand and exploding rocks. The cloud drops vast quantities of boulders and ash over the surrounding land, but when it rains there's a new danger. Water mixes with ash into a heavy mud flow, covering fields and villages, powerful enough to carry huge boulders along with it. In the past, volcanoes like Merapi have erupted with cataclysmic effects. In 1883, the island of Krakatoa almost blew itself off the face of the earth. Ash was propelled to a height of 80 kilometers. It blocked out the sun and plunged the region into darkness for 2.5 days. It caused a tidal wave 36 meters high, which drowned over 30,000 people, sweeping around the world several times. The explosion was heard in Australia, over 3,000 kilometers away. But volcanic eruptions are not the only effect of the Earth's plates moving together. Crustal plates don't always slide smoothly, one under the other. The oceanic crust can meet fierce resistance, so it slows or sticks, like a machine without oil. The pressure builds up until suddenly the plate is forced forward. pressure is released, sending shock waves through the Earth's crust. This first earthquake is often followed by a series of aftershocks. Directly above the focal point, on the surface, is the epicenter. Shock waves are often felt far away. Mexico City was 400 kilometers from the epicenter of the devastating earthquake of 1995. Not all earthquakes result from plates moving together at destructive margins. The Golden Gate Bridge, San Francisco. Here in California, on the western coast of the United States, people are living on a time bomb. This densely populated area is frequently hit by earthquakes. One of the largest occurred in 1906. Downtown San Francisco was reduced to rubble, causing fires which burned for 3 long, hot days. San Francisco is built on the edge of the North American plate, next to the Pacific plate. The boundary between the two is called the San Andreas Fault. This has been caused by the two plates sliding past each other at a rate of 5 centimeters a year. The fault extends underneath this lake for over 1,500 kilometers from San Francisco south through California. At present, Hollywood, Los Angeles, lies 650 kilometers south of the Golden Gate. Both plates are moving northwest, but the Pacific plate is moving faster, and in 12.5 million years, Hollywood will be north of San Francisco. The Himalayas. This is the highest mountain range in the world, and it's getting higher all the time. Every year, Mount Everest grows by 1 centimeter. These mountains are caused by the collision of two plates of continental crust. They're called fold mountains because the layers of different rocks within the Earth's crust, the strata, are folded and bent. Over time, erosion of the layers can occur at different rates, producing characteristic jagged rock formations. The Himalayas mark the boundary between the Indian plate and the Eurasian plate. There, two sections of continental crust are moving towards each other. The world's major fold mountains, volcanoes, and earthquake zones all lie on or near the boundaries between the Earth's tectonic plates. All are in constant motion, powered by the Earth's intense inner energy.